All right, so here we have a problem where we're given a quadratic function, basically a parabola, and we're asked to give the coordinates of the vertex. And so I think I'll do that one right away because what I need to remind you of is that whenever you have a function that is given in this form, it is called the vertex form, and it's generally going to look something like this: a times x minus h squared plus k. And so the h and the k is the vertex. And so it's real easy to derive that from this example because um, the 20, well, let me do it down here. Because we've got 5 times x minus 23 squared minus 20. Now it's mostly obvious, but there could be a little bit of confusion. So the h is the 23 without the minus sign. But the k is the 20 with the sign. That's probably the main confusing thing. Um, if we look at another example, which might be helpful just to understand what's happening. If you had been given g of x equals, let's just say 2, and then x plus 1 plus 2, you would need to know that you should rewrite this as x minus -1, but keep the plus 2 as is, because then the -1, 2 would be your h and your k, which is indeed the vertex. So you may need to review how to use the formula and how to find the right signs. That's sometimes confusing for students. Okay, now as far as part B, it says explain how g of x is transformed from this original parent function. So the way I would think about it is I would notice that if the parent function is y equals x squared, there's a couple of things that are happening. One of them is a minus 23 has been inserted. Now I'm going to put that minus in black And to again, sort of in alluding to the same issue that it's the positive part that is telling us what's happening, and the what's happening is that the original function, which looks like this, is being moved 23 units to the right. And so with just this minus 23 change, now you've got the same exact function, the same shape, transformed or shifted to the right 23 units. Then you have the minus 20 part. The minus 20 is now shifting the curve 20 units down. So imagine the same exact shape, but now it's being moved down. And it's being moved down specifically 20 units. This minus sign actually does indicate down, whereas this 23 indicates right. So that's one of the things that if you haven't already grasped that you need to go back and take a look at. And then the final thing that's happening is this 5 over here. And what it's doing, it is stretching the curve vertically. So it's a vertical stretch. So the things that are happening, um, the way it's being transformed is the original graph or curve, if you want to use that language, is shifted to the right 23 units, to the left 20, no, I'm sorry, down 20 units, and vertically stretched by a scale factor of 5. And that's how it was transformed. Now it says, what are the zeros of the function? That's part C. Um, Let me think of the easiest way to do that. Okay, so to do part C, what I am gonna do is delete some of these things that are on the screen just to give me more space to work with. And I really mainly need, I can work with just that piece because we're being asked to find the zeros. So what I'm going to do is I'm going to set g of x equal to 0. So this is part C. And I am going to add 20 to both sides. So I've got 20 equals 5 times x minus 23 squared. I'm going to divide both sides by 5. And I'm left with x minus 23 squared equals 4. I'm going to take the square root of both sides and continue the work over here. So I've got a plus or minus 2 equals x minus 23. Add 23. We're almost there. I know it's kind of a long problem because there's a lot of parts. So it's 23 plus or minus or plus and minus. Whoops. 2 equals x. So my two possible answers are 25 and 21. Those are my two zeros, and now we've covered every part of this problem.